Hello, welcome to our channel for probability and statistics. In this video, we will talk about the partition of total variability and estimation of sigma square in linear regression. So this figure shows the linear regression or simple linear regression between y and x. And this line is the true, a real linear relationship between x and y. But we never know this epsilon between observations and this real line. So this is the estimation of the relationship between y hat and x. So y hat is the mean value for given x. So this line is the linear regression line. Y hat equals b0 plus b1 times x. So b0, b1 are the coefficients of linear regression. And the real observations, the difference between the observations and the point on this line called E1 is the error term. So the coefficients of linear regression, B1 equals this formula, and B0 intercept is this formula. So next, we go a step further. There are three notations. S-sqaure is the sum of squares between x and x bar, and S-sqaure is sum of squares between y and mean of y, and S-sqaure is cross product, sum of the cross product of x from x bar and y from y bar. So if we look back, so x bar is odd x values average between, from this regression line, odd x values. And the y bar, of course, is also for odd observations average. So these three notations. Then we look back again. So B0, x bar, y bar minus B1 times x bar. And B1 is this formula. If we check this formula, actually is S-sqaure in denominator and S-sqaure in the numerator. So B1 is xy divided by S-sqaure. Next, we'll check the error sum of squares, ESS or SSE. SSE is the sigma of the squares. So inside the squares is the y value minus the regression or the mean value of the regression for given x. If we check the figure again. So SSE actually is the sum of squares of this EI. And this EI is the difference between real observations and the regression value of given x. So the difference between real observations and the point on this regression line, this difference is EI, and the sum of squares of this EI we call SSE. So SSE is the sum of squares. Squares is yi minus b0 minus b1xi. So take square. And we go details for the mathematical manipulation. We can get the result of SSE is SYY minus B1SXY. So these two notation we have seen here, right? And next we will talk about the estimate of the sigma square. So what is the sigma square? If we look back to this figure again, so this is the real unobserved, we never know this real line, but actually there exists and such line, right? Such line depicts the relationship between x and y. And here is mu x given x, y, and beta 0 plus beta 1x. So we write this coefficient here because we never know. Actually, we use a linear regression to estimate this one. But for this real one, between observations and this real line, this is epsilon. And this epsilon confirms the hypothesis that this error, no matter which x value, this error follows an identical and independently distributed random variable, and this random variable in linear regression has normally distributed. And for the normal distribution, this random item has a variance called sigma square, or the variance of this normal distribution. And if we plus this one, this epsilon, then here will be the real y. So epsilon follows normal distribution with variance sigma square, which means the real value y also have variance sigma square, because beta 0 plus beta 1 times x, actually this is the deterministic term, then plus a random term of epsilon. So y value will follow this normal distribution. And in a simple linear regression, or say only one x independent variable, so the estimate of sigma square has this form. So this called S-square is an unbiased estimate of sigma square. And the calculation of S-square is SSE divided by n minus 2. SSE is the sum of squares of y minus y hat. So y hat is b0 plus b1 times x, right? So this is SSE, and SSE divided by n minus 2 will equal S2. So in simple linear regression, S2 equals SSE divided by n2. And SSE also equals SYY minus B1 times SXY. And B1 is the linear regression coefficient estimation. So here y divided by n minus 2, not divided by n, because 2 means we lost 2 degrees of freedom in estimation of this linear regression, because there are 2 parameters. Because when we calculate SSE, we use 2 parameters. One is B1, another is B0. Because when we calculate B1, we use B0 also. So there are 2 parameters lost. That's why we divided by n minus 2 here. But square is an unbiased estimate of sigma square. Thanks for watching.